Hi, Elliot Severn here. It's going to be a clear night, and I'm going to show you how I do astrophotography here in my backyard in Connecticut. Alright, so here's my fully set up astrophotography rig. The telescope on top is an Orion ED100. It's a 4-inch f9 refractor, and on the back of it is a Nikon D610. It's a full-frame SLR camera, and on top of it is a little 80mm Meade guide scope with an Orion Starshoot auto guider on the back. Now all of this is sitting on top of a Sirius EQG German equatorial mount, which can find objects and track objects throughout the sky as the Earth rotates. So this axis here is the polar axis, and it's aligned with Earth's North Pole. Now inside the polar axis, if you turn the scope sideways, a little hole opens up in the front, and we have a polar alignment scope that sits inside there. So at night, I'm going to aim this at the North Star, but the North Star isn't exactly aligned with Earth's North Pole. So if we look through this polar scope here, you're going to see there's almost like a little clock in there. So my computer is going to tell me where to put the North Star on that clock, and that will align the mount with the Earth's North Pole. Now when the telescope is free to move, it turns on this axis in what's called the right ascension axis. So the telescope and all the gear I have on here is balanced perfectly with these weights on the end. And as you can see, with one finger I can move the whole thing, and it'll stay anywhere I put it. Now this is its tracking axis. So after it gets aimed at an object, its motors will kick in, and it will rotate slowly in right ascension, and it'll do one complete turn every 24 hours. So as our telescope is aimed at a star, as that star moves throughout the sky, it's going to keep it in the telescope the whole night. It also has another axis that helps it aim at other parts of the sky called the declination axis, which is when the telescope's moving this way. And using both right ascension and declination, you can aim at pretty much any part of the sky. And it's computer controlled, so all I have to do is click on an object and click Go To, and the telescope will move to the object by itself. As the mount is tracking objects in the sky, its tracking isn't perfect all night long. It has little periodic error. And when there's error, our stars aren't nice and sharp and round in the final image. So that's where the auto guider comes in. So as our main camera is exposing, the little auto guider camera is staring at stars through this little scope on top, and it's tracking any movement of those stars. Now if they move even the tiniest bit, even under a pixel, it tells the mount how much tracking error there is and how much it should compensate for. So I can expose for hours upon hours at a time, and it will keep every star perfectly stationary on our final image. And there's one more thing I'm experimenting with. every deep space image requires hours of exposure time. And so I would have to sit outside for hours at a time, even entire nights. And on cold nights, especially, I don't want to do that. So I've set up some remote control on this telescope. Alright, so here's my hand controller, which runs the mount. And I've also installed a Raspberry Pi, which is running StellarMate OS. Now, StellarMate OS allows me to operate the mount and the camera and the auto guider over my home Wi-Fi network from the comfort of indoors. And that makes astrophotography for nights at a time a lot easier. Alright, so here's what I see after I get inside. So we are in a program called K-Stars. It's a free open source astronomy program, and it gives you a map of the sky, and it tells me where my telescope is now. And I can click any object and tell my telescope to go to that object. Now if I go over here into the Ecos tab, this has all my controls for astrophotography. So on this screen, I can run scripts and I can watch my current exposure. I can run my tracking status, see how everything's operating. Over here are the mount controls. I can control the mount position and its tracking. Over here are the camera controls. I can set all my camera settings over here, and I can set up scripts to run exposures all night. Over here is alignment, so this is where I frame up my images. And over here are the auto guider controls. So I can snap an image through the auto guider. I can click on a star, and then when I click guide, it will keep that star in the same position on the image, and it will show me a graph of my tracking error and the corrections that the mount made. So that's a quick overview of K-Stars in Ecos. I'm going to be imaging some galaxies tonight. Everyone have a great night and clear skies.